Good day, everyone. So, today we shall be looking at questions and answers on electrolysis. All right, let's dive in. Example 1 question says copper of mass 0.33 grams is liberated by passing 100 coulombs of electric charge through a copper voltmeter. Calculate the mass of copper deposited when a current of 2 ampere is passed through the voltmeter for 5 minutes. Alright, so we write out our parameters to solve this problem. So we have a mass of 0.33 grams, that's mass M1. That is the mass liberated, the first mass liberated when this 100 coulomb of charge passes through the voltmeter. So, and the 100 coulomb of charge is our Q1. That's the initial charge that was passed through, and the mass, the initial mass that was liberated. Now, what if a current of 2 ampere is now passed through the same voltmeter in 5 minutes? Then we need to obtain the charge from this current, the final charge. So the final charge, which is our Q2 by formula, charge is product of current and time. So Q2 is I2 times T2, and that is our I is 2 ampere, that's 2 times our time, which is 5 minutes. We have to convert it to SI unit, which is in seconds. So 5 minutes to seconds will be 5 times 60, and that is 300 seconds. So to get our Q2, that will be I2 times T2. Our I2 is 2 ampere, and our T2 is 300 seconds. So 2 times 300, that's 600 coulomb. So the question is, we have to calculate the mass when the charge is 600 seconds. When the charge was 600 coulomb rather. When the charge was 100 coulomb, we have a mass of 0.33 grams. But now that the charge is now 600 coulomb, what will be the quantity of mass liberated? So to determine that, we use this formula: mass M1 over Q1 equals M2 over Q2. And then we know our M1 is 0.33, so we substitute it. So we have 0.33 over Q1, which is 100, over 100 equals to M2. And that's what we are looking for, the unknown, over Q2, which is 600. And when you simplify this, our M2 will be 1.98 grams. Very straightforward, right? Now let's go on to another example. Example 2 says a charge of 1 coulomb liberates 0.0033 gram of copper in an electrolytic process. How long will it take a current of 2 ampere to liberate 1.98 gram of copper in such a process? Alright, the same thing applies just like in example 1. This time around, a mass of 0.0033 gram was liberated. So our M1 is 0.0033 gram. Now, this was liberated as a result of the charge that was passed through it. That was 1 coulomb of charge. So our Q1 is 1 coulomb. Now, we are now to determine the time it will take to liberate 1.98 gram of mass, that's M2, if a current of 2 ampere, which is our I2, is passed through it. So in this case now, we have our I2, we do not have our T2, all right? And that's what we have to look for, because we have to look for how long it will take. Okay, so we need to determine our Q2. Our Q2 is I2 times T2. Our I2 remains 2 ampere. But our T2, which is what we are looking for, is unknown. So 2 times T2, that's 2T2. Now, bringing into our formula says M1 over Q1 equals M2 over Q2. Our M1 is already 0.0033 gram, that's it. Our Q1 is 1 coulomb over 1 coulomb equals our M2, in this case, is 1.98, which is 1.98. But our Q2 is 2T2. So we substitute our Q2 here with its value 2T2. So instead of writing Q2, we have 2T2 here. And when you cross multiply this, we have 2T2 multiplied by 0.003. And that will give us 0.00662. Then 1 times 1.98, that's 1.98. Of course, dividing both sides by 0.0066, our T2 will be giving us 300 seconds. Very straightforward. Okay, let's take another example. It says, in an electrolytic experiment, a cathode of mass 5 grams is found to weigh 5.01 gram after a current of 5 ampere flows for 50 seconds. What is the electrochemical equivalent of the deposited substance? Okay, so as usual practice, let's set our parameters out. Now we're told that in this experiment, a cathode has a mass of 5 grams, so that the initial mass, this MI represents the initial mass of the cathode. So the initial mass of the cathode is 5 grams. But it now happened to weigh 5.01 gram when a current of 5 ampere was passed through it. So the final mass of that cathode happened to be 5.01 gram. So it means there is an increase in the mass of the cathode. So something must have increased that. Okay, and that is the liberation of the liberation of the substance. Now, for us to now determine the liberated mass, so our liberated mass will now be the final mass, which is 5.01, minus the initial mass, which is 5. So the liberated mass is 5.01 minus 5, and that's 0.01 gram. We are given another parameter here, that's the current, which is I. I happen to be 5 ampere, and we are given time, which is 50 seconds. We have to find the electrochemical equivalent, that's Z. We use Z to represent electrochemical equivalent, or sometimes we just say E.C.E. But most of the time we use Z. So Z is the unknown right now. Okay, so we've obtained the liberated mass, which is the M here, to be 0.01 gram. Then the charge, usually we need to calculate our charge too. Our charge is current times time. Our current is 5 times our time, which is 50, that is 250 coulomb. Then the electrochemical equivalent, which is Z, is mass over charge. Our mass, elevated mass, is 0.01 over our charge, which is 250. That will give us 0.0004 gram per coulomb. That is the SI unit for electrochemical equivalent. Okay, let's take one example again. Here it says copper of thickness D is plated on the cathode of a copper voltmeter. If the total surface area of the cathode is 60 centimeters squared and a steady current of 5.0 ampere is maintained in the voltmeter for 1 hour, calculate the value of D, that is the thickness now. So we are given density of copper to be 8.9 times 10 to the power 3 kilogram per meter cube. We are also given Z, and that is our electrochemical equivalent of copper, to be 3.3 times 10 to the power minus 7 kilogram per coulomb. Alright, so in this case, we had to calculate our D. Based on the questions, to calculate the value of D. So D is the unknown one here. The next parameter, we are given the area, the total surface area of the cathode to be 60. So A, which is the area, is 60 centimeters square. But then we need to convert our centimeter square to the SI unit, that is meter square. So to converting 60 centimeters square to meter square, all you need to do is to divide 60 by 10,000, and that will give us 0.006 meters squared. Another parameter given there is the current, and the current, which our I is 5.0 ampere. Then lastly, we are given the time, which is 1 hour, but we need to convert our time to seconds. So 1 hour to seconds will be 60 times 60, which is 3,600 seconds. And another thing we are given in the bracket is the density. The density is obtained by this symbol called rho. So density is given to be 8.9 times 10 to the power 3 kilogram per meter square. And we are lastly given the electrochemical equivalent, that is our Z, to be 3.3 times 10 to the power 7 kilogram per meter cube. But then we need to calculate our charge. Our charge by formula is always IT, that's product of current and time. So current here is 5, that is 5 times our time, which is T, that's 3,600 rather. So multiply by 5, that's giving us the result here. So that's giving us a result of 18,000 coulomb. Okay, 18,000 coulomb. Now, subtracting the value here, so we now come to the formula to get our thickness, which is D now. The formula is electrochemical equivalent multiplied by charge over density times area. So electrochemical equivalent, which our Z is given, so we have 3.3 times 10 to the power minus 7. Our charge, which is 18,000 coulomb, this is here, 18,000 coulomb, that's it. So all over the density now, which is 8.9 times 10 to the power 3, in this is it here, multiplied by our area, which have been converted to meter square, that's 0.06 meter square. When we simplify all of these, our final result will be 0.0011 meters. All right, so that is the thickness of the plates, okay, of the copper. All right. Okay, so let's go to the last example, and here we have when a current of 1.0 ampere flows in an electrolyte for 3 hours, a mass of 1.0 gram is deposited. What mass will be deposited in 10 hours if a current of 3.0 ampere flows through the electrolyte? Alright, so we have initial current, which is I1 to be 1.0 ampere. We have initial time also to be T1, and that's 3 hours. We need to convert it to seconds. So 3 hours to seconds will be 10,800 seconds. That multiplying it by 3,600. So that will be 10,800 seconds. Then we have initial mass of 1.0 gram. Now, this mass was deposited when this current was passed through. Now, when the current was now 3.0 ampere, that is our I2, and a time of 10 hours was spent, which is in seconds is 36,000 seconds, multiplying it by 3,600 seconds. What will now be the new liberated mass, M2? Very simple. So we need to calculate our Q1, which is I1 times T1. Our I1 is 1. Our T1 is 10,800 seconds. So our Q1 is now 10,800 coulomb. Okay. Our Q2 is I2 times T2. Our I2 is 3. Our T2 is 36,000 seconds. So multiplying it together is going to be giving us 108,000 coulomb. That's our Q2. Now, bringing into our formula, we know our formula is M1 over Q1 is equal to M2 over Q2. All right. So our M1 is 1. So we have 1 over our Q1 with obtaining to be on 10,800 coulomb, and that's it here. Then our M2, which is what we are looking for, all over our Q2, which we have obtained to be 108,000. Okay, so substituting all this value here and then simplifying. When you simplify this, our M2 will be 108,000 over 10 1,800, and that will give us 10 grams. All right, so this is what we shall be drawing the curtain for today. Thank you for listening. Bye for now.